Turbomachinery Pelton wheel. And now we would like to discuss about design aspect of Pelton wheel. There is a few things or a few equation we need to know before we could solve Pelton wheel problems. One is velocity of jet. The velocity of jet at inlet is given by this equation. Sometimes we use V1 or sometimes we use Vjet, and it be calculated by using this equation, CV times square root 2GH. And CV is the coefficient of velocity and it is around 0.95 to 0.99. And H here is the H effective of the Pelton wheel. Velocity of wheel. The velocity of wheel is given by u pi dn over 60, and it also can be calculated by using phi times square root 2gh, and n here is rotation per minute in RPM. Next, the speed ratio. The speed ratio is the ratio between the velocity of wheel and velocity of jet. It can be simplified by using this symbol, phi. And the amount of the phi here, or the speed ratio, is between 0.43 to 0.48. Angle of deflection. The angle of deflection of jet after striking the bucket is taken as 165 degrees if no deflection angle is given. It is because to make sure that the water will flow down after hitting the bucket without interrupting each other. We will see the location of this angle in next lesson. Next, a jet ratio. It is defined as the ratio of the pitch diameter, capital D, of the Pelton wheel to the diameter of the jet, small d. It is denoted by M, and it could given as M equal capital D over D. The jet ratio lies between 11 to 16 for maximum hydraulic efficiency. However, in most of the cases, it is taken as 12. Bucket dimensions. Bucket dimensions are designed in such a way that its breadth should be 3 to 4 times of diameter of jet. Its length should be 2 to 3 times of diameter of jet, and thickness should be 0.8 to 1.2 times of the diameter of jets. Number of jet. It is obtaining by dividing the total flow rate through the turbine by the flow rate of water through a single jet. It can be written like this. Number of jet is equal to total flow rate divided by total flow rate for one jet. In general, number of jets are limited to 2 in case of vertical runner, as we showed you previously, and 6 in case of horizontal runner. Number of bucket. The number of bucket on a runner is given by Z equal 15 plus D over 2D equal 15 plus 0.5 m, which capital D here is the pitch diameter, the small d here is the diameter of the jet, and m here is the jet ratio.